Okay, quick adjustments here. I had to change 10 centimeters to 1 millimeter and 5 centimeters to 0.5 millimeters. This was because I chose a graph with a period that is too small. Alright, so this is an example problem. Process is going to be the same. That's going to be what is most important. So the answer is going to be a little bit on the nonsensical side, but if we're looking to find the period, because we want to find the length of the pendulum, go through one cycle. If we go through one cycle, we start here, go all the way up, come down. Once we get back to the start, we find that it's roughly, the period would be 0.2 seconds. Okay, so now I have the period for the pendulum, 0.2 seconds, really short period. Alright, so we're going to look at how the period relates to length. We have t is equal to 2 pi radical L over g. Okay, if I solve for the length here, we're going to have t squared is equal to 4 pi squared times L over g. Got rid of the square root, squared everything else, so then it'd be t squared is equal to t squared g is equal to 4 pi squared is equal to L. So t squared g over 4 pi squared equals L. And if we solve for what L is, we find that L is going to be a really small number, 0.001 meters or 1 centimeter. So this would be the length of that pendulum. Like I said, I chose a graph with a very small period, so that's why the length is extremely small for the pendulum. So what is the expression for position as a function of time? We have x is equal to a times cosine omega, which would be 2 pi over t times t. Okay, we know in this case, this is 1 millimeter would be the amplitude. So it would be 0.001 meter times cosine 2 pi over 0.2 seconds times t. You could also, for 2 pi over 0.2, you could write this as 10 pi would also be omega. So you could write this as cosine 10 pi omega t. That would also make sense. Either way, that would be the expression for position as a function of time. And if the amplitude decreased to 0.5 millimeters, what would the period be? Well, we know that for a pendulum, it's only dependent on the length. Therefore, by decreasing the amplitude would not have a significant effect on this.